Today we're going to talk about sequences. So first let's define what a sequence is. A sequence is an ordered set of numbers whose domain is the set of natural numbers. And just in case you need a reminder what those are, natural numbers are 1, 2, 3, 4, 5, etc. So it starts at 1, goes on up to infinity, but no decimals and no fractions. Now one thing that's worth noting is that the range can be anything. So the range or the output can be anything. Okay, so just to clear up what this means. When we have a sequence, which we'll look at some examples in just a moment, we can only plug in the natural numbers, 1, 2, 3, 4, 5, 6, and so on. Our output, our result, our range can be anything. It's fine if you plug in 1 and you get 2/3, or if you plug in 5 and you get 0.7. Your output can be fractions and decimals, or normal natural numbers. It can be either one. So there's no restriction on what your result can be, just on what you're allowed to plug in. Now let's look a little bit at notation. If you remember, notation just simply means how we write something. So if you have brackets like this, it's kind of like Jay Leno's profile with the big chin. This represents the entire sequence. Whereas if you just write it without the brackets, this just represents one term. This would be the nth term. So for example, a sub 1 is the first term, a sub 2 is the second term, and so on. You could do like a sub 12 is the 12th term. Did I spell that right? 12th? Yeah, I think so. And all of these are called subscripts. So these right here, they're called subscripts. So you can call it a sub 1, a sub 2, a sub 12, or you can just say a1, a2, a12. Either way is fine. You might be asking yourself at this point, so what do we do with sequences? Well, let's start looking at that. First thing you need to know how to do is to find the first 4 terms of a sequence, or first 5 or whatever. I'm just using 4 as an example. You may need to find the first several terms of a sequence. Okay, and this is what's called the explicit form of a sequence. And that just means if you want to find the 5th term, you plug in 5. If you want to find the 10th term, you plug in 10. If you want to find the second term, you plug in 2. So that's all we have to do. If we want to find the first term, notice our 1 is our n. So I plug in 1 for n. So to get the first term, I do 3 times 1 plus 4. So that gives me 7. For the second term, I do 3 times 2 plus 4. And that gives me 10. The third term, I do 3 times 3 plus 4, which gives me 13. And for the fourth term, I do 3 times 4 plus 4, which is 16. So the first 4 terms are 7, 10, 13, and 16. And you may be able to do that in your head or more quickly than I just did it. That's fine if you can. But you just need to find those first 4 terms. So let's try another one. And for this one, let's do -1 raised to the n over 3 to the n minus 1. Okay, now this one may be a little complicated to do with your, by hand, excuse me. So we're going to do this one with our calculator. So give me just a moment and I'll pull up the calculator and show you how we can do this. Alright, so here you see your calculator. We're going to go to y equals, and we're going to plug in -1 raised to the x. We can just use x instead of n, that's no problem. Divided by parentheses 3 to the x minus 1, and then close the parentheses. You had to put those parentheses there to take care of the fact that it's in the denominator and you want to divide by the whole thing. Alright, one thing you should do is make sure that your table is set on ask. So go to second table setup, and you want it to be on ask for the independent variable only. So this is what you want it to look like. Independent ask, dependent auto. Now when you go to your table, you can plug in whatever you want. You can plug in any number you want. So since we want the first 4 terms, I do 1, enter, 2, enter, 3, enter, 4, enter. And that gives me the numbers I want. So in case you can't see those very well, it's going to be negative 0.5. Uh-oh. See if I can pull that back up. Positive 0.125. Negative 0.0385. And I believe the last one was 0.0125. Notice it alternates between positive and negative. That's actually because of that negative 1 to the n. If you think about it, anytime you raise a negative number to a odd exponent, it stays negative. But if you raise it to an even exponent, it becomes positive, and that's the reason that happens. So I want to say again, this is called the explicit form. These sequences are written in the explicit form. The recursive form is used, let me reword that, sorry. The recursive form uses previous terms to define the current term. And we'll see an example of that in just a minute. Okay, so for a recursive form or sequence, find the first 4 terms of this recursive sequence. Now with recursive sequences, they always have to give you at least the first term. They have to give you at least that much. Excuse me, sorry, I'm fighting a little bit of congestion. A1 is equal to 5, so the first term is 5. And then here's how they write the rest of it. They say A sub n is equal to 3 times A sub n minus 1 plus 2. Alright, now that may look really confusing. One other thing I need to add here, this is only true for n is greater than or equal to 2. In other words, we only use this equation, this second part, when we're finding the second term, third term, fourth term, and so on. We cannot use it to find the first term. Okay, but these subscripts just tell you what term you're using. So in other words, if I'm trying to find the third term, then I need to plug in the second term. Or if I'm trying to find the 7th term, I need to plug in the 6th term. That's all that's saying. So you're using the term just before the one you are trying to find. So for example, if I want to find the second term, I'm going to do 3 times A1 plus 2. So notice, my subscripts are just 1 different from each other. 2 is my n, so n minus 1 is 1. And I know what my first term is. It was given to me. It's 5. So I do 3 times 5 plus 2, which is 17. So for my third term, I do 3 times the second term plus 2. And I just found the second term. It's 17. So 3 times 17 plus 2 is 53. And the fourth term, 3 times the third term plus 2. So we get 3 times 53 plus 2. That would give us 161, I believe. So if you notice, what we're actually doing each time is multiplying our number by 3 and then adding 2. If you do 5 times 3 is 15, plus 2 is 17. 17 times 3 is 51, plus 2 is 53. 53 times 3 is 159, plus 2 is 161. And if you notice, we're always using our previous term to get our next term. That's called a recursive sequence. The downside of recursive sequences is, number one, some people get really confused with all these subscripts, but the real big deal is if you want to find the 10th term, you have to find terms 1 through 9 first. And that's not so bad with lower numbers, but if you want to find the 100th term, you'd rather not have to plug in and figure out the first 99 terms. With the explicit form, which is what we had a second ago, if I wanted to find the 100th term in here, I would just plug in 100 for n. So in general, explicit's more useful, but some sequences are actually far, far simpler using the recursive form. Often when you switch from the recursive to the explicit, explicit becomes much more complex. So we'll look at both throughout this unit. Let's do one more example where we're trying to find the first 4 terms. Let's say that our first term is 3. So a sub 1, that means the first term is 3. And then a sub n equals 2 times a sub n minus 1 plus 5. All this is really saying is that you should take each number, multiply by 2, and then add 5. And then take that number, multiply it by 2, and add 5. Take that new number, multiply it by 2, and add 5. This is called a recursive sequence because you're using your previous term to get the next term. So a2, let me add one thing here. So it only works for the second term on up. So I do a2 equals 2 times a1 plus 5. So that's 2 times 3 plus 5. 2 times 3 is 6, plus 5 is 11. So notice, I just multiplied my first number by 2 and then added 5. So now I multiply my second number by 2 and add 5. That gives me 27. Then I just multiply my third number by 2 and add 5. And that gives me 59, I believe. So that's how you work with recursive sequences. We need to briefly talk about something called a factorial. So let's talk about a factorial. I don't know if you've seen these before or not, but I think the simplest way is just to start with an example. 3 factorial, that exclamation point means factorial. Means you do 3 times 2 times 1. And that gives you 6. 6 factorial would be 6 times 5 times 4 times 3 times 2 times 1. So you can see you multiply all the numbers together from 1 up through whatever you're doing the factorial of. And that's how you work that. I think this one's 720. Let's go ahead and pull it up in the calculator and check me on that, because we can do factorial in the calculator. So we'll go back to our main screen, and if you go to Math, and then go all the way over to Probability, the fourth one down is factorial. And I forgot to plug in a number, so let's back up. 6 is what we want to check, so 6, Math. If you want to just hit left, it'll switch over to Probability there for you. And then go down to the fourth one, or just press the number 4. You get 6 factorial, and that is 720. Now factorial gets really big really fast. For example, if you do 20 factorial, 20, think about $20, not a huge amount of money, but if you do 20 factorial, watch how big this number is. 2.4 times 10 to the 18th. So you're talking about something like 2.4 quintillion. So factorials get ridiculously big, ridiculously fast. So I just wanted to make sure, in case you see any factorials, you're welcome to always do those in your calculator. There's nothing wrong with that. You don't need to know how to do them by hand at this point. Okay, there's actually one other thing I need to tell you about factorials. That is, 1 factorial is obviously just 1 because it's 1 times itself. And actually, I know this may not make sense, but 0 factorial is also equal to 1. That's actually just considered a definition. They've just chosen, the great math gods have chosen that 0 factorial is equal to 1. There's not necessarily any reasoning behind that except that it's convenient and it makes things work better. Last thing we're going to talk about are series. Series are the sum of a sequence. So I think I can illustrate this pretty quickly for you. A sequence would look like this. 1, 2, 4, 8, 16, and so on, where I'm just doubling each time. That's a sequence. A series is 1 plus 2 plus 4 plus 8 plus 16, and so on. So a sequence is simply a list of numbers. A series adds all those numbers together. And one of the main ways we're going to handle series is through something called sigma notation. Okay, so sigma notation. Okay, here's a sigma. It's a Greek letter. Looks kind of like an E. This is sigma. Sigma simply means add. Well, that's how it's used in math anyway. And let's say you put something down here. This is called your index of summation. It simply means it's the variable you need to plug in your numbers into. Okay, this is your starting point. It's the first number you should plug in. And then up here you put your end point. I'm just going to call it n for now. It's the last number you should plug in. You can call it your start and your stop, or your start and your end, anything like that. And then over here will be your equation, and this is called the ith term, or the general term. And you can use any variables you want. You can use n or k or x or j, or anything is fine. So let me show you real quickly how to do this by hand, and then I'll show you how to do it in the calculator. So let's say we have this sum. This is telling us to plug in 1, 2, and 3 into this equation and then add the results together. So again, this variable tells you where to plug in your numbers. So we start with plugging in 1 right in here. So I get 2 times 1 plus, and you just count up. So I plugged in 1, so next I plug in 2, and next I plug in 3, and because I've got a 3 up top here, I stop at 3. So I get 2 plus 4 plus 6 equals 12. So that's how to do it by hand. You simply just plug in the bottom number first, keep counting up and plugging those numbers in until you get to the number on top, and then add them all together. And the last thing we need to do today is learn how to do these in the calculator. So let me pull up the calculator again. Depending on the addition of your calculator, it depends on how you do it. Let's see what this calculator has. If we go to math, let's see, it's going down. May have gone too far. Huh. Apparently I did. Alright, let's see. Okay, this calculator does not have it. Some of your calculators under Math 0 will actually say summation, and it'll look almost exactly like this, and you just have to fill in the blanks. You'll just have to fill in, usually put x here, then your number here, and then your number up top, number up top, and then your equation. If you don't have that, another option, which is what I'll have to do with this, is use sum of the sequence. Remember, that's the definition of a series, is the sum of a sequence. So if you go to your calculator and you go to second stat, that's actually under list, then go over to math. The fifth one down is sum, and then you go back there and go to OPS. The fifth one down there is sequence. So for the one we just did, you would want to plug in the equation first. So let's look back at what we had. It was 2n from 1 to 3. So here's how I can plug this in. The sum of the sequence, then you plug in the equation, then you do comma x. The reason you put that x there is to let it know what your index of summation is, what variable you're plugging into. I just generally always use X in the calculator. You can use the different letters you want as long as these two match. That's all you got to make sure of. Then you put your starting number in there and your stop number in there. So let's just plug that in the calculator and make sure it gives us what we wanted. We do 2x, comma x, comma 1, comma 3. And it should give us 12, and it does. So that's how you can do that in the calculator. It's really helpful with ones that are more complex or ones that are simply bigger. So keep that in mind. So I'm going to now copy and paste your homework for this section up on the board, and good luck.